They did a good job of melting the chocolate, but the marshmallow's not as gooey as I would like.
Welcome to UU Kids Science.
In a moment, we're going to use an experiment with ants to see how different types of food sources provide different types of energy. Then we are going to do our SunSmore demonstration. Finally, we're going to hear from Gabrielino Tongva Elder and UU religious educator Gloria Liggett on what it means to care for the earth versus respecting our connection with the earth. An ecosystem is a group of organisms that share an environment. You may have seen ecosystem food chains that look something like this. The plant absorbs energy from the sun. The plant-eating animals eat the plants. The animal-eating animals eat the plant-eating animals. The reality is much more complicated and involves a lot more bacteria and fungi.
Let's look at the relatively simple case of my adorable house cat, Tigran. Tigran is not allowed outside and so has a very controlled environment. The food chain Tigran is a part of would look something like this. The grain gets energy from the sun. The chickens eat the grain. Tigran eats the chicken, mixed with pea protein and alfalfa and a number of supplements with unknown origins, although sometimes the ants eat the chicken instead. In either case, it is only partially digested by the animal. The rest is broken down by bacteria and then digested. Tigran also enjoys wheatgrass and the occasional lizard.
Most plants get energy from the sun, soil, and air. Animals consume energy as sugars, fats, and proteins. Sugars are the least complex, while proteins are the most complex. The more complex the molecular structure, the longer it takes to break down and the longer the energy lasts. We can explore these energy sources by seeing what types of food ants prefer. To do this experiment, you will need to place 4 cardboard squares a foot away from an anthill. Then add your bait. Since we are in a drought, and the ants might be attracted to water, I use powdered egg whites for protein, oil for fat, sugar for sugar, and table salt for non-energy providing white powder. As you can see, the ants preferred the egg whites, or the protein, though they also explored the sugar and the oil. This is because the complex protein molecules contain a lot of energy they can bring back to their nest. Next, let's try to capture some solar energy for ourselves by making a sun oven and using it to make SunSmores. I got this project from NASA Climate Kids, which is an excellent source of climate lessons for kids. I've included the link here and in the description. To make the oven, you will need a box. The NASA directions say it should be large enough to fit a pie tin, but you may want to experiment with thinner boxes. More on that later. Additionally, you will need aluminum foil, clear plastic wrap, scissors, tape, a marker, a glue stick, a straight edge. Not shown here, you will also need white school glue. Finally, you'll need an adult with a box cutter. If you have an open box like this one, tape up the sides to make sure you keep the heat inside the box. Then, use a marker to draw a square along 3 edges. You will cut along these edges to create a lid that can fold up and catch the sun. Next, get an adult to help you use a box cutter to cut out the lid. Make sure to only cut along the 3 edges so the lid stays attached to the box. Next, we will cover the inside of the box with foil. If you want to conserve foil, measure each side of the box and cut the foil to fit exactly. Otherwise, cut off large pieces of foil and then cut them to shape. Glue the foil to each side of the box with the glue stick. The Climate Kids directions say to make the foil as smooth as possible, so use your hands to smooth it out and try to make sure it covers all of the corners. I also went in and added tape along each corner to try to keep the air from escaping. Next, we're going to apply 2 layers of plastic wrap. Since they are sticky, I recommend you do each separately. The directions say to attach the plastic wrap with tape. I only have this packing tape, and the pressure I used to make it stick to the box caused the cling film to rip. So I first attached the film with glue. I taped the edges to create a seal. Next, I realized I had no way to put stuff in the oven, so I cut a door in the front using the box cutter. Again, get an adult to help you with this part. To make the s'mores, you will need graham crackers, chocolate, and marshmallows. I'm using Dandy's vegan marshmallows because I have a corn allergy and they use tapioca syrup instead of corn syrup. However, you will want to use non-vegan marshmallows if you can. More on that later. You will need to preheat your oven outside. Use a stick to prop up the oven lid to catch the sunlight and let it sit for half an hour. I used an oven thermometer to keep track of temperature changes. Put the marshmallows on top of the graham crackers in a pie tin and then put the pie tin in the oven using an oven mitt. Let them bake for at least 30 minutes. The directions say to add the chocolate at the end on top of the graham crackers if you are using bar chocolate. I like really melty chocolate, so I use chocolate chips. Notice how shiny they are? That is because they have already started melting in the sun. I plan to take them out once they have melted and quickly reheat them towards the end. Things did not go as planned.
So after following the location of the sun for 2 hours and replacing the rock to try to get a better angle, what we have is somewhat melty chocolate, and slightly warm marshmallow.
2 hours for mildly warm marshmallows felt like a waste of time, so I decided to see if I could get better results by trying the test closer to noon and using a towel to insulate the oven door. I also tried mini marshmallows, but they did not work well at all. I used a meat thermometer so I could look at the effects of cooking over time. The ideal temperature for s'mores is between 150 and 160 degrees Fahrenheit. After 30 minutes, the non-insulated marshmallow came close at 140 degrees Fahrenheit. After an hour, the outside temperature had lowered and the marshmallow only got to 135 degrees Fahrenheit. The insulated oven had similar results, with 135 degrees Fahrenheit after 30 minutes and 132 degrees Fahrenheit after an hour. Frustrated, I wrote NASA Climate Kids, and they very kindly got back to me that day, saying I should try the oven on a day that is at least 85 degrees Fahrenheit. Unfortunately, it does not often get that hot in Santa Barbara in June. So I checked weather station reports and found one an hour down the road in Ojai that was closer to the range they suggested. I also decided to try regular corn syrup marshmallows, as I had read that the vegan ones use a seaweed gelatin that has a melting point of 158 degrees Fahrenheit, while the animal-derived regular gelatin melts at 95 degrees. I had an assistant this time. However, due to time constraints, I only had 10 minutes to preheat the oven and 30 minutes to bake. Predictably, neither marshmallow reached melting temperature. However, the oven had an internal temperature of 150 degrees Fahrenheit. To see if the Ojai experiment could have worked if I had more time, I set our regular home oven to 150 degrees. The regular marshmallow only reached 127 degrees Fahrenheit after half an hour, but by then it was already really gooey. The vegan marshmallow heated up more quickly, but never got gooey, even after it reached the ideal temperature of 150 degrees. I've melted these over a campfire before, so I know they can melt, but they likely need a higher temperature to do so. I'll have to wait for some warmer weather to do some more experiments. If they work, I'll let you know. Meanwhile, if you want to try it on your own and live someplace cooler like Santa Barbara, I recommend you use non-vegan marshmallows. A flatter box, like a pizza box, may also work better because there's a larger surface area for the tinfoil to absorb heat relative to the amount of air that needs to be heated. If you do get it to work, let me know in the comments below. Next, Gloria Liggett will talk about thinking of ourselves as part of an interdependent environment rather than environmental protectors.
Yes, I'm Gloria Liggett. I am part of the RE, on the RE Council. I was the RE director at the Unitarian at Live Oak for several years, a while back. And I work here a lot. I'm here a lot with the Chumash people, doing a lot on their maritime board. I'm a member of that, but I'm actually a Gabrielino Tongva from the San Gabriel area.
I asked you about Native views on environmental protection, and you indicated that was just the wrong way to think about it. How so?
There was a constitution of something about the environment, and they invited Native people to come and be part of it. And we listened, and we were part of it, and we were divided up into committees, into little groups. But all of us separately in our group said the same thing. Wait a minute, you're approaching this from a whole different angle. You're approaching it as if we are like it's a triangle. We're up at the top, and we're taking care of the earth. We're caregivers, but actually, we're part of the all living things, of the whole web of life. We are, we call the birds and the deer and the rocks and the rivers all our brothers and sisters. And so when you look at all things that live on the earth and things that aren't, the trees, the flowers, the sage, all that, as are each of them a relative, then you have a whole different idea of how to care for the environment. You care for the environment as part of the environment. When you think of everything as a relative, you think of it differently. You wouldn't do the things that we do to living things. We would just have a whole different. We would have a whole different relationship to the plants, to the animals, to the fish, to the birds, if they're our brothers and sisters.
Our seventh principle is respect for the interdependent web of all existence, of which we are a part. In class, we say, we care for our earth. Are these the same thing?
Many of our principles that we translate for the children don't mean what they mean to the adults, and the kids certainly would understand the web, that we're part of the web of life. So I'm not one that thinks we need to so much translate all of them. Saying that we're part of we're part of the web of life. We're related to everything. We're all relatives, not just that we're caring for the earth. Because you can care for the earth and not be relatives to all the plants and the animals and the rocks and the trees.
How did Native people develop this model for our relationship to the environment as part of our family?
It's just part of you, and it's part of Native people. It's how because everyone relates to the living things that way, and not just the living things. Just like we were saying, when you pick sage, or when I take the Wilderness Youth kids out to pick the plants to make baskets with, we always say thank you. We always, and with adults, we leave a little bit of tobacco as we cut anything or bring anything in that we're going to be using for baskets or for whatever. We would never think to not say thank you. I mean, you say thank you when somebody gives you something, and when we receive something from a plant, we say thank you. And it's just sort of what we do. And but at that meeting that I was telling you about, people thought that was very strange with a lot of the things that we said.
Why is it important for us to see ourselves as part of the environment and not just its protectors?
People were saying they were upset because coyotes were out in the city now that there haven't been. And it's like, wait a minute, why shouldn't they be? They're part of this land. We're on their land too. We're sharing it with them. Why wouldn't they be part of that? And if we were told that the ocean, we were related to the ocean and everything in it, we wouldn't be throwing stuff in it the way we do, we wouldn't be treating that ocean because they're our relatives. We don't treat our relatives that way. But it comes from a loving, caring way because we're related. You treat even, your cousins are different to you than your friends. You might love them all both, but there's that something else that's a little different if they're related to you. So if indeed everyone felt like they were related to each other and to the earth, we wouldn't be treating each other nor all the animals and plants the way we do. We just wouldn't.
Survival is a delicate balance. Life needs energy and heat, but too much of it can kill. As the world warms, we're seeing ocean acidification, rising sea levels, and melting icebergs, all deadly disruptions to our interconnected ecosystems everywhere. We often think the way to care for our Earth is to make individual sacrifices, like driving less, or not using plastic straws, or making your cat go vegan. As we've stayed home in the past few months, we've driven less and flown less, and we are projected to have a 5% reduction in carbon emissions this year. However, we need a 7.6% drop every year to avoid the worst effects of climate change. So we've confirmed that individual sacrifices may help, but will not save the planet. Stanford professor and chair of the Global Carbon Project, Rob Jackson, recently suggested to the LA Times that if we were to transform our economy into one that ran on electric vehicles and more people worked from home long term, we could buy ourselves enough time to develop strategies that will work. What is clear is that we can't see protecting the environment as something we do on our own. We need to lobby our governments to include environmental protections in the way we plan our cities and build our society. As Gloria indicated, we need to think of ourselves as an integrated part of the environment and plan accordingly. Upcoming classes include COVID-19 Part 2 with Dr. Fielding Miller, Decisions and Unconscious Bias, Making a Rube Goldberg machine with stuff around your house, All About Chocolate, and Optical Illusions.